So this is a really hard question, and I think under exam conditions, I would probably be skipping this question. So let's look at how best to go about it. And the key thing is, how do I relate these two pieces? And what I'm actually going to do is, instead of these, I'm going to use to relate x plus y plus z to that. And then you'll notice, because I can replace y with minus y minus z. So whatever relationship I have here will apply here by just replacing it with minus y and minus z. So where have we seen these pieces? Well, if we look at this square, we know that we'll get x squared plus y squared plus z squared, and then 2xy, 2yz, 2zx. Okay, so that's one relationship we know. The other one is these set of inequalities, and some of you may have seen this. If you start with that x minus y squared, which is always greater than or equal to 0, because you're squaring some number, whether that's positive or negative. So if you expand that, you'll get this relationship. And what we're going to do is to apply that to the other two variables as well. And again, the reason is we're trying to link up these pieces, which we kind of see here. And then we'll have x squared plus z squared. So if I add these three inequalities, I'm going to get 2x squared plus 2y squared plus 2z squared is greater than or equal to 2yz plus 2xz. So I need to relate this and this, so I'm going to actually need to eliminate that. So I'm going to take this and substitute that here. So we'll have, yeah, I mean, doing all this in the exam, unless you already know the result. So I'm subtracting this term here and then substituting that here. So that will become that. So we end up with this inequality that relates these two. So let me complete this. This would be 3x squared plus 3y squared plus 3z squared. That. So you'll notice here that if I replace y with minus y and z with minus z, then this will become, because these are squares, so they remain that way because you're squaring minus y, whereas this side will become x minus y minus z. And this is kind of what the pieces we have. So next I'm going to do is to substitute those here. That piece becomes 3 times x squared plus y squared plus z squared, which is a over 4. And then here, x minus y minus z is, let's see, actually I need to make sure this is a square. So that would be 3 plus a over 4 square. So this is going to help me get to what a is. So I'll do the work here. Sorry, it's kind of getting squeezed here. And then square numerator and denominator. So that would be 9 plus a squared plus 6a over 16. Strike that out, then multiply it by 4. And we'll get, I'm kind of flipping the terms here, 12a. And then if I subtract 12a, we'll get this, and then this is a minus 3 squared is less than or equal to 0. Well, this is always positive, a minus 3 squared, so it can't be less than 0. Only possibility is that it's equal to 0, which means a must equal 3. The answer is D. This is the only way I know currently to do this question. Maybe there's an easier way, picking numbers, some other, at least I'm not familiar with. So yeah, it's a difficult question. I would likely just skip this in the exam. In any case, you don't have to get all of them right, which I think very few people do. So this would be a good candidate to skip. But make sure that you kind of understand the logic here and these basic inequalities. I think that relationship is important. That one is. And I think this is also useful. So just make sure you kind of know how to do these manipulations. But to summarize, the answer is D.